So today's portion, what we are going to see is about a three-phase motor. So this three-phase motor mainly of two types, induction motor and synchronous motor. Most important is the induction motor. 80% of the industrial application, we use this type of three-phase induction motor. And 50% of our global power consumption is also by this three-phase induction motor. So this is the three-phase induction motor is widely used in many industrial application, onboard applications also. So we will see what is the construction detail of stator, rotor, working principle of the induction motor, and applications of onboard application, industrial application. Those things we'll discuss it today. So this three-phase induction motor is also called a self-starting machine. There is no excitation. There is no shaft connection, prime mover. It is a self-starting machine. Also, this type of motor is also called a subsynchronous motor. It cannot attain the speed of the synchronous speed. So it is also called subsynchronous motor. So one by one, if we see, you will understand what is subsynchronous motor, why it is called as a self-starting machine. So those things we will see in this. And generally, a motor is called as electrical energy is converted into mechanical. Generally, electrical energy is converted into mechanical form is called as a motor. And stator construction is, the stator is of two types. One is star connected one and another is delta connected one. So in the star connected, each phase, this is displaced by 120 degree. This angle is 120 degree. So this angle is 120 degree. This R, Y, B, each angle is 120 degree. It is displaced. And we are giving RYB supply. Three-phase AC supply is given to the three-phase star-connected network or a delta-connected network. That is the stator construction. This is going to produce a rotating magnetic field. So this will produce RMF. That is the rotating magnetic field. This rotating magnetic field will sweep over the rotor construction. That's what we are going to see. So even though the stator part is a stationary part, this is not a running part, it is a stationary part, but the field which is produced from the stator part is a rotating part. So this is a simple construction about the stator. So we can also see how the stator looks like. Just a minute. This is, I'm sharing one small video. In this we can see how the stator is looking like. This is stator. Outermost part is called as the stator. And inside we have the silicon steel stamping, rolled gold laminated one. So this is stampings. Group of stampings are taken and it has formed as a slots is formed. In these slots only they will be winding the wires. So that will be in RYB star connected network or it will be in RYB delta connected network. So this type of construction is made. So this is how they are winding in the stator. So this is the construction details. We'll pass here and we will get back to the slide. This is our slide. And next one, the three-phase current flows simultaneously through the winding and are displaced from each other. As I have told, this star connected is being displaced by 120 degree. This is star, no? This star connected winding, this angle is 120 degree. RY, this angle 120 degree. And each alternating phase current produces its own flux, which is sinusoidal. So all three fluxes are sinusoidal and are separated from each other. So the total produced from this is called rotating magnetic field. So physically, the stator is not rotating, but the field produced is rotating in the space with a constant amplitude. There will be a constant amplitude. Three phase will be producing a constant amplitude. Our connection this way, three be produced with a constant amplitude. Now, the stator has a laminated type of construction. So we have seen that in that video, how the stampings are made, and it is of 0.4 to 0.5 mm thickness. And the stampings are slotted. So it had a slots that also we have seen in that video. In that slots, it will carry the stator winding. So you can go back to and see my lecture, that video you can see if you want some more clarity, better clarity. The stampings are insulated from each other. So to keep the iron losses to a minimum value. The number of stampings are stamped together to build a stator core. So a stator core is produced. So this is the construction detail of the stator. Now we will go to rotor construction. So rotor is of two types. The rotor is of two types. One is called a squirrel cage rotor and another one is called a slip ring wound type of rotors. So squirrel cage means it is looking like a cage here. The rotor copper bars are shorted. The rotor copper bars are shorted like this. And this is end rings, aluminum end rings are there. And so the rotor core is cylindrical and slotted. The rotor consists of uninsulated copper or aluminum bars. So the rotor is consisting of strong aluminum and copper bars. Heavy copper bars which is shorted. And with the help of copper rings called end rings. And we have this type of end rings also. Now, for better understanding, we will see some video on this construction, how it looks like. Just a minute, I will open a video. Yes. So here, we will see what is the rotor construction. So this is rotor, this is rotating part that will be connected with a shaft. This rotor. So these are the bars, copper bars, shorted bars with end rings will be there. When they are shorting, if the transformer is shorted in the secondary winding, there will be a heavy current in that. We have open circuit. Open circuit, there will not be flow of current, but it is shorted like this. See, the copper bars are shorted. Very heavy current will be flowing inside that. Because to make it a self-starting machine, the construction is such way. So they are shorting the copper bars. Now we will get back to the slide. Yes. So this is cage type. It looks like a cage. So this is also called as cage type rotor bars. The bars are usually brassed to the end rings to provide a good mechanical strength. The entire structure looks like a cage forming a closed electrical circuit. So the rotor is called a squirrel cage rotor. As the bars are permanently shorted, the entire rotor resistance is very small. So shorted circuit will have small resistance value. Open circuited will have infinity resistance value. These things are basics we have to understand. If the transformer secondary winding is shorted, it's very low resistance value. But when it is in open, this is for the space resistance. So that is infinity. So this rotor is called a short circuited rotor. And one more type is there. Up to now, we have seen what is squirrel cage rotor type. Next one is called slip rings. So slip ring is also one of the type of induction motor. The rotor carries a three-phase star or delta connected distributed winding wound for the same number of poles. The rotor construction is laminated and slotted. So So the slip rings, it has these types of rings and brushes. So the maintenance work is little bit more as compared to this full gauge type. This is called slip ring induction motors. The slots contain the rotor winding. This is star connected rotor. Star connected rotor construction is there, and that is connected to the slip rings, which is having brushes, and externally connected rheostats are also present. So this is one of the another form of rotor construction. So in stator, we have two types. One is star connected and another is delta connected. It depends upon what is the torque, what is the application, where the motor is used. So that type we have to design the induction motor and we have to use it. In rotor construction, we have two types. That is, one is squirrel cage and another one is called slip ring. So in this type of rotor, the external resistance can be added with the help of. So here they are adding the external resistance in series. This is one form of slip ring induction motor. So we'll go for the next. So this is difference between the squirrel cage and the slip ring induction motor that we will see at the last. We'll go for the next. Working principle of this type of induction motor. First of all, three-phase AC supply is given to the stator. As we have said, three-phase, this is three-phase AC supply. I'm giving to the stator, three-phase. Right, properly. Three-phase AC supply is given to the star connected or a delta connected. So that will be producing a rotating magnetic field. We know this. This is called rotating magnetic field. And rotor is placed inside that. This is a strong copper bars, aluminum copper bars with the end rings, conductors. So this conductor is placed in the magnetic field. So when it is placed in the magnetic field, a flux is produced, and that flux will induces a current in the rotor conductor. See, there is an induced current in the rotor conductor. This induced current, since the rotor bars are shorted, it is in a closed circuit, that will drive a voltage. An EMF is induced in the conductor. So first we will see what is written in the slide. Then I'll again explain this diagram. When a three-phase supply is given to the three-phase stator winding, a rotating magnetic field of constant magnitude. So RMF is produced. This RMF will be sweeping over the rotor. It tries to move the rotor. So this RMF will be in a synchronous speed. It will be in a constant synchronous speed. So this is called a synchronous speed. The RMF will be in a constant synchronous speed. The formula 120 F by P. Speed is equal to 120 F by P. So this NS is called a synchronous speed. This RMF will now cut the rotor conductor. As it tries to sweep over the conductor, whenever the conductor cuts the flux, EMF is getting induced. That is according to the Faraday's laws of electromagnetic induction. Now, we will see this diagram. So, this is rotating magnetic field is produced, and here rotor conductor is cutting this. So there is an induced EMF is produced in the rotor. That induced EMF now will drive a current since the circuit is closed. Now it is driving an induced current in the rotor conductor. Now we will get back to this. So that is by the principle, the EMF induced is by the principle of Faraday's laws of electromagnetic induction. As rotor forms a closed circuit, induced EMF circulates a current through the rotor. So that is rotor current is produced. Is given by the Lenz's law. And according to the Lenz's law, the direction of the induced current in the rotor is as to oppose the cause of producing it. So the cause of the rotor current is in the induced EMF. So now what is happening is, we'll get back to the next one. So now what is happening? Oh, there is an induced current in the rotor. So this is kept in the magnetic field. A flux is produced around this rotor conductor. This flux, there is no relative speed difference between your rotating magnetic field and your rotor speed. If there is no relative speed difference, there is no difference in the speed, the rotor cannot run. The rotor will be at 0 RPM. It cannot run. But initially the slip will be maximum. The slip is it is lost in the air gap. Slip will be maximum. So there should be a relative speed difference between your rotating magnetic field as well as your rotor speed. So what is happening? There is two fluxes in this. One flux is called weaker flux. It is here you can see addition of fluxes. So when the fluxes is in the same direction, these fluxes will get added. When the fluxes are in the different direction, that will get cancelled. Cancellation of two fluxes. The low area fluxes will get cancelled. So the speed of the rotor is getting reduced. So rotating magnetic field in the synchronous speed. Rotor speed is a different speed. So there is a relative speed difference between these two. This relative speed difference will make the rotor to move. A mechanical force is produced, a torque is produced that will drive the rotor. There is no excitation, no current is given, but the rotor sweeps and the rotor starts to rotate. So that is called as self-starting machine. But it cannot attain the rotating magnetic field speed, RMF speed, because it is always less than that speed, because there should be a relative speed difference. Initially, it is lost in the slip. When there is an equal speed, it cannot rotate. So there should be a difference. So these low flux areas will get cancelled. The fluxes which is getting in opposite direction will get cancelled. And the same direction of the fluxes will get added together. So when there is difference in the flux, that will get cancelled and same fluxes will become twice the flux and that will sweep the rotor. The rotor starts to rotate. This is the working principle of the induction motor. So the NS is called as the speed of the RPM, that is your rotating magnetic speed. NS is the synchronous speed. So speed of the rotor is in RPM. NS minus N is the relative speed difference between the two. So there should be some relative difference speed. So where it is lost in the slip. So it is mandatory. Then only the machine will become self-starting. Otherwise, if it is in both the speed is same, it will be in the standstill condition only. Speed will become 0. Rotor speed will become 0. Then this way, it is becoming a self-starting machine. Now, you will see what is the applications of. This is application of three-phase induction motor. So this is used in lift, cranes, exhaust fans, engine auxiliary pumps, engine blower, fan motors, and engine room heavy load pumps, ballast, freshwater, seawater, winch motor, windlass motors, crane motors, propulsions, blowers, seawater pump motor. So these are all industrial applications and ship onboard applications. They use induction motor. Widely it is used. That's why they say that 50% of the consumption of global power is by the induction motor. Since it is inductive in nature, it is a lagging power factor also, and it consumes powers. Okay. Now, in between, we have one slide that is the difference between a slip ring induction motor and squirrel cage induction motor. So first, a squirrel cage motor, the rotor consists of bars. So it is a copper bars, strong, heavy copper bars which is shorted. So shorted will have a resistance very low, 0 resistance, very low. If it is open circuited, it will be infinite, but it is shorted. So it will be having very low resistance or very high current. 4 times, 6 times, there will be a very high current flowing through the copper bars. Here the rotor consists of 3-phase winding. So rotor and the stator is of as like same. Stator is of star connection and rotor is also of star connection type. The rotor is of three-phase winding, similar to the stator winding. Here the construction is simple. Robust construction, simple construction, and this construction is complicated because it has brushes, it has slips, ring curvatures, and these things, whenever there is a slight spark or something, that may rupture the brushes and other things. So this is complicated and maintenance will be high. Resistance can be added externally. They are adding the resistance. Here permanently shorted, so we cannot add anything inside. Slip rings and brushes are present to add the external resistance. So rings are present, brushes are present to add resistance. So, or absent. Here no maintenance is less here, no slips and brushes. So here, this is a very important point. Frequent maintenance is necessary. Maintenance is free. Rotor is costlier. Rotor are cheap. High starting torque. This one is moderate starting torque. Rotor must be wound for same number of poles. Rotor automatically adjusts itself for the same number of poles. Rotor resistance starter can be used. Rotor resistance starter cannot be used. They are connecting external rotor. So that is used, but here it cannot be used. Rotor copper losses or high, hence efficiency is less. Rotor copper losses or less, efficiency is high. So rotors are made up of silicon steel stamping, gained gold silicon steel stamping. So to reduce the losses, reduce the machine loss, copper losses, and other things. The speed control by rotor resistance is possible. Speed control rotor resistance is not possible. The resistance is connected outside in slip ring. Here it is not possible. So this is used in lift, hoist, crane, elevator, compressor. This is used in lathe, drilling machine, fan, blower, water pump, grinder, printing machine. This is moderate starting torque. This is heavy starting torque, high starting torque. So we have some difference between the both. So mostly squirrel cage is used on industry because simple in construction and maintenance free. That is more important. So depends upon applications also. What type of applications we are using. See here they have given the application lift, hoist, cranes. These things can be run by slip ring. Lathe, drilling machine, blower, water pump, grinder. These things have to be run by squirrel cage. So today we have seen the working principle of three-phase induction motor. This is having two types inside that. One is called stator and one is called rotor. Stator is of two types. Stator is of star connected and delta connected. The star winding is displaced by 120 degree. When three-phase AC supply is given to the star connected, it produces a balanced sinusoidal rotating magnetic field. This rotating magnetic field will sweep over the rotor. So according to the Faraday's laws of electromagnetic EMF, an EMF is induced in the rotor conductor. This induced EMF will drive a current in the rotor, and this current will produce a flux. And there are two types of flux, low flux and good flux. The flux which is at the low is getting cancelled, and the flux which is good is getting added up, and it tries to sweep the rotor. This is the simple short I'm saying last. Simply, what is the how to define the working principle. Okay, thank you. I understood.